Hello, very good evening, everyone. So, as you all know, that today we are going to cover the JPYQs, which has been came in the previous day examinations. So, let's start with the today's topic, which is NCRT Chapter 2 Electrochemistry, JEE Part 2. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using the generative AI, which is experimental. Okay, so let's begin with our first question, which is a JEE PYQ question, and it covers the section of NCRT which is marked as 2.4 in the chapter Electrochemistry. The question says that the correct order of equivalent conductance at the infinite dilution of LiCl, NaCl, and KCl is. So we have given three ionic compounds: lithium chloride, sodium chloride, and potassium chloride. You have to tell the correct order of equivalent conductance at infinite dilution of these three ionic compounds. And you have given the four choices, the four options. So the options are: LiCl is having the highest equivalent conductance, then NaCl, and then potassium chloride, or potassium chloride is having the highest equivalent conductance, then sodium chloride, then LiCl, or sodium chloride is having highest equivalent conductance, then potassium chloride, then LiCl, or the LiCl is having the highest equivalent conductance, and then KCl, and then NaCl. So these are the four options given. That means different orders are given. You have to tell the correct order of the equivalent conductance at infinite dilution for these three ionic compounds. Okay, so got some time and try to remember the relationship between the equivalent conductance, that means the conductance or conductivity, and the dilution and the concentration, and then try to relate these ionic product conductivity to that. Okay, and then try to solve this, and you have some time, go through it, go through the question, and then we will see the correct answer. Okay, so let's see. So for this given question, the correct answer is option B. That is potassium chloride having the highest having the highest equivalent conductance, then sodium chloride, and then Li. Okay, so let's see how. Okay, so first of all, as you know that I am, we are seeing some GPYQs from the chapter Electrochemistry basis on the concept which we have already covered in this chapter. Okay, so try to make this session more, you know, like, okay, so try to answer the questions and try to solve the questions which we are providing here. Okay, okay. So let's see the solution for this question, that how this will be the correct order for the given ionic compound. So in these three compounds, which is LiCl, NaCl, and KCl, the anions are same. That is chloride, right? So if you see, as I said, that these three are ionic compounds, that means if they dissociate, they will dissociate into the positive ion and the negative ion. In the case of LiCl, the positive ion will be Li positive and the negative ion will be Cl negative. In the case of NaCl, it will be Na positive and Cl negative, and in KCl, it will be K positive and Cl negative. Right now, if you observe, the Cl negative, that is the anion, is same in three of the compounds. Cations have same charge but different size. Okay, and if you see that these three ionic compounds have different cations but same anions, and also the cations charges is also same, like Li plus, that is 1 plus, Na plus, that is 1 plus, and K plus, that is again 1 plus, right? So K plus, Li plus, and Na plus all are having 1 plus charge, right? So the cations have the same charge, that is plus 1, but different size. But their size is different because their configurations are different, right? They are different element. So the number of already present negative charge onto the different elements are different, and that is why whether there is positive 1, positive 2, or whether there are same charges on these elements, the size will always be different. Smaller cations, if the cations means the positive charge ion, smaller cations are more heavily hydrated in the aqueous solution, giving larger hydrated radius and thus smaller ionic speeds and equivalent conductance. What they are saying, that if the cation is smaller, and how can you determine whether it is smaller? So if any ion is having positive charge, as much as the positive charge is greater, like either it is having one a positive, two positive, or then three positive. So which cation will be the smallest? The three positive one, right? So smaller cations are more heavily hydrated in the aqueous solution. When you hydrate those smaller cations, they will easily or heavily hydrated. They will they will easily get hydrated. They will easily get dissolved in the water in the aqueous solution, which is giving larger hydrated radius and thus smaller ionic speeds. Okay, because when they interact with the water molecule, they will form the complex, or they will react with the water molecule and give a larger hydrated radius, because they will react with the water molecule, right? The radius will increase and thus smaller ionic speeds, and due to that the ionic speed will get decreased, because now they are not only ions but they have reacted, combined with the water molecule for the hydration, right? That means their ionic speed will be decreased due to the increased hydrated radius and equivalent conductance, and also their equivalent conductance will also decrease due to the decrease of the ionic speed. Therefore, equivalent conductance follow the order: highest for the KCl, then for the sodium chloride, and then for the lithium chloride. Now, if you compare the the equivalent conductance, you can also compare it through the size, as I said. Okay, so as you know that potassium is having the largest side among the potassium, sodium, and lithium. Lithium is the smallest in the size. If it is smallest in size, that means when it react with the water molecule to give the hydration energy and to become hydrated, it will react with the water molecule and form a little more bigger radius molecule, right? Compared to the potassium, if you compare it with the potassium has already the largest size among these three cations or among these three elements. When this react with the water molecule and combine with the water molecule, it will make a larger hydration radius, and the uh, ionic speeds will affect effectively, right? So that is why this is the order for the equivalent conductance of the given three compounds. So highest equivalent conductance is observed in the KCl, then in the NaCl, that is sodium chloride, and then the lithium chloride. Okay. Now, if you go on the basic of the equivalent conductance, which is just a definition that it is a measure. Equivalent conductance is basically conductivity, okay, and it is measure of conductance of a solution which is containing one equivalent of the electrolyte. This is basically the definition. Okay, so our correct answer is option B, that is this order. Okay, so as I explained that you can give this order by relating the conductivity with the size and with the dilution process. Okay, because we are considering at infinite dilution what is the equivalent conductance of these three ionic compounds. Okay, let's move to the next question. Now, this question is also a JEE PYQ and it covers the NCERT section 2.5 in the chapter Electrochemistry. Now, the question is saying that the quantity of silver which is deposited when 1 coulomb charge is passed through silver nitrate solution is. What we are asking, we are asking about the weight of the silver or the quantity of the silver which is deposited when, what condition? When 1 coulomb of charge, coulomb is the unit of the charge, okay, coulomb is represented by C. So we are here using the 1 coulomb quantity of charge to pass through the silver nitrate solution. Then what is the amount of silver which is deposited? That is the question which we are asking. Okay, this question has been into the 2024 means examination in the second session. So the options provided are 1 electrochemical equivalent of silver, 1 chemical equivalent of silver, 1 gram of silver, or 0.1 gram atom of silver. So you have to tell that which option represents the correct quantity of the silver depositing in this given condition as per the question. Okay, you got some time, try to solve it, then we will see that which option is the correct answer. Okay, so let's see. So for this given question, the correct answer is option A, that is 1 electrochemical equivalent of silver. So the quantity of the silver which has deposited is equals to the 1 electrochemical equivalent of silver. Now the amount of substance which is deposited is given by Faraday's law. Okay, so Faraday's law, we also, remember we studied the Faraday's constant, right? So Faraday's law, Faraday has given two laws of electrolysis, the first law and the second law. So the amount of substance which is deposited via passing of the current or the charge through the solution, electrolytic solution, that amount is given by or determined by the Faraday's law. So W equals to ZIT. Each term represents its correct meaning. W equals to ZIT, where I is the current, T is the time, Z is the equivalent conductance, and W is the amount of the substance which is deposited. W is also defined as ZQ because Q is equals to IT. Q is the representation of the charge. We represent the charge by Q. Okay. Charge unit is coulomb, which is represented by C. But the representation of charge itself is Q. So Q equals to current times time. So as you know that we have I into T and I into T is Q. So we put Q at the place of I times T. So W will become Z times Q. Now Q, that is the charge, will become equals to W by Z, right? You just cross multiply it, and W equals to QZ, right? As per this equation, W equals to QZ. Now when Q equals to 1, if you put the charge equals to 1, which is already given in our question that 1 coulomb is passed, 1 coulomb charge is passed through the silver nitrate solution. So when the charge is equals to 1, then the W, that is this quantity W will become equals to Z, because according to the W equals to QZ equation, if you put the Q as 1, W will become equals to Z, right? Where Z is a electrochemical equivalent, and hence the A option is the correct answer. Okay, Z here is representing a electrochemical equivalent, and W, the weight or the amount of substance we are requiring, is becoming equals to the electrochemical equivalent, and the Q is becoming 1 because it is already mentioned in the question that when 1 coulomb of charge is passed. So when Q is 1, the W is equals to the Z, that is the amount of substance deposited is equals to the electrochemical equivalent. Hence, we have the correct answer as option A, that the quantity of silver which is deposited is 1 electrochemical equivalent of silver. Okay, so let's move to our next question. This is a JEE-PYQ, and this is covering the NCERT section 2.4.2. Okay, in the chapter Electrochemistry. Okay, now let's continue. So the question we are going to start is molar ionic conductivities of divalent cation and anion are given as 57 and 73 Simon centimeter square mole inverse. So we have given the molar ionic conductivities value. Molar ionic conductivities value of divalent cation and anion. What do you mean by divalent? That means it is having two something charge, two positive or two negative, both for the cation and anion respectively. So the molar ionic conductivities of divalent cation and anion are 57 Simon centimeter square mole inverse and 73 Simon centimeter square mole inverse respectively. Okay, that means for cation it is 57, and for anion the value of molar ionic conductivity is 73. The molar ionic conductivity of the solution of an electrolyte with the above cation and anion will be. Now you have to tell the molar conductivity of a solution of an electrolyte which is formed with this given cation and anion. Okay, so after mixing the cation and the anion part, we got the electrolyte, right? Now this electrolyte solution molar conductivity you have to determine. This question has been in the 2024 mains examination. The four options given are 130 Simon centimeter square mole inverse, 187 Simon centimeter square mole inverse, 260 Simon centimeter square mole inverse, or 65 Simon centimeter square mole inverse. Okay, I am calling again and again Simon. So basically Simon is this S. Okay, S is a representation of Simon. Simon is the unit. Simon is a unit which we use in the measurement of some quantities in this chapter. Like in the molar conductivity, we are using the Simon as one of the units, right, for the measurement. S is representing the Simon unit. So you have these given four options for the value of the molar conductivity. We have already given the value of molar ionic conductivities of the cation and the anion. And when you combine these two and make a electrolyte and make the solution of electrolyte, then that solution's molar conductivity is what you have to identify. You got some time, try to solve it, and then we will come to the correct answer for this question. Okay, let's see. So for this given question, the correct answer is our option A, that is 130 Simon centimeter square mole inverse. This is the value of molar conductivity. So let's see first of all that what is given. We have given the molar ionic conductivity value for the cation and the anions. So the ionic conductivities for the cation, for the divalent cation. Okay. First of all, if you remember the Kohlrausch law, we studied about the before that we have studied about the molar conductivity of the electrolyte, right? The whole electrolyte. And then we have studied about the molar conductivity of the cation and the molar conductivity of anion, right? Similarly is what we are representing here, lambda C2 positive. 2 positive because already given divalent cation and anion. Okay. So C is representing the cation having the 2 positive charge. So the ionic conductivity of the divalent cation is given as 57 Simon centimeter square per mole. And similarly, the ionic conductivity of the anion, divalent anion, is given as 73 Simon centimeter square per mole. These are the two quantities we have given already in the question. Now, the molar conductivity of the solution of the electrolyte, which is made by these two, cation and anion, is given by. So, the molar conductivity of the solution is defined as the sum of the ionic conductivities of particular ions present in the solution. Okay, this was the equation for that. So, we have already given the lambda value for the cation and the anion. So, we just have to add them both. So 57 plus 73, this will give you 130 Simon centimeter square per mole value, right? So this is a value of molar conductivity of our solution, which is made up of the electrolyte, which is formed by combining the cation and anion given. Okay. So the lambda of the solution, that means the molar conductivity of the solution as per the Kohlrausch law, is defined as the sum of the ionic conductivity of their particular ions. So we just have to add their ionic conductivity. We have already given the ionic conductivity for cation and anion. We have added them and the final comes out as 130. Hence, we have the correct option as option A. Okay, so A option is the correct answer for this question. Okay, let's move on to the next question. Okay, now this is again a JEE PYQ and this is covering the NCERT subsection 2.4.2 under the section 2.4 in the electrochemistry chapter. The question is saying that for a strong electrolyte, a plot of molar conductivity against the concentration to the power half is a straight line with a negative slope. The correct unit for the slope is. So what question is saying? Try to understand. This question has been into the 2024 mains examination. The question is saying that we are taking a strong electrolyte. Strong electrolyte is meaning that this electrolyte dissociate completely when we dissociate it into the water or some solution. Okay. it will dissociate into its constituent ions. So for the strong electrolyte, a plot of molar conductivity, when you plot, that means when you draw a graph between the molar conductivity, which is represented by lambda m, so molar conductivity against concentration to the power half, that means under root c. So when you plot a graph between these two quantities, it will be a straight line with a negative slope. That straight line has negative slope. So you have to tell the correct unit for the slope. The four options given are Simon centimeter square mole to the power minus 3 by 2, liter to the power minus 1 by 2, Simon centimeter square mole inverse liter to the power half, Simon centimeter square mole to the power minus 3 by 2, liter to the power half, or Simon centimeter square mole to the power minus 3 by 2 liter. You have to tell the correct unit of slope. Okay. How can you do that? First of all, you have to relate the given quantities among them so that you can get the equation for revealing out the unit of the slope. Okay. So it is already given that we are taking a strong electrolyte, we are plotting its molar conductivity versus the concentration under root concentration graph. You are getting a straight line with a negative slope and you have to tell the unit of slope. Okay. So you have to relate all of these terms together in a form of equation, which or in a form of concept if you remember from the theory part, and then you can solve it. So you got some time, try to solve it, and then we will see that which option is the correct answer. Okay, let's see. So for this given question, the correct answer is option C, which is Simon centimeter square mole to the power minus 3 by 2 liter half. Okay, let's see how. So the units of the molar conductivity. So the molar conductivity is this, which is represented by lambda m also. The molar conductivity is represented by the lambda m, and the units of the molar conductivity we use is Simon centimeter square mole inverse. Now the concentration unit and to the power half. So concentration is unit is basically mole per liter. Okay, and when you take the half of all this unit, it will become mole to the power half, liter to the power minus half, because denominator will go in the numerator and the plus half will become minus half, right? So mole to the power half times liter to the power minus half. This is the unit of the concentration under root. Now units for slope. So slope, how can we identify the slope? If you know the graph concept, we have a graph with a straight line having a negative slope. So graph is something like that. Okay. Now slope is defined as so this is the molar conductivity at the y-axis and this is under root c at the z-axis. So the slope is this, the ratio of this and this quantity. Okay, y by x is basically the slope. Y is our lambda m, that is the molar conductivity, and the x is our under root c, which is the concentration to the power half. So we just have to put the these two things in the fraction to get the unit of slope. Okay, understand? So what we do, units of slope, that is unit for slope, will be equals to the unit of molar conductivity, that is lambda m, divided by the unit of the concentration under root. Okay, now we know the both units, so you just have to divide them. If you solve them, let me solve for you. So unit of molar conductivity we know is Simon centimeter square mole inverse, right? Okay, Simon centimeter square mole inverse was the unit for the molar conductivity, divided by the unit of the concentration to the power half. The half power concentration will be mole to the power half, liter to the power minus half, right? Now if you solve it, the numerator will be same. This denominator thing will go in the numerator and the mole will only change and the liter power will only change. So it will become Simon centimeter square mole. Now here minus 1 is already present. 1 by 2 in the denominator go in the numerator and become minus 1 by 2. So minus 1 minus 1 by 2 will be, here 2 will go in the numerator. So basically we take the LCM. Now minus 2 minus 1 will become minus 3 by 2. So this will become equals to minus 3 by 2. So mole to the power minus 3 by 2, and liter will go in the numerator. So liter will go in the positive power and the final unit will be this. So the final unit will be Simon centimeter square mole to the power minus 3 by 2 liter to the power 1 by 2. This will be the unit of flow, and hence the C option is the correct answer. Okay, so let's move on to our next question. Now, this question is again a JEE PYQ, and this question is covering the NCERT section 2.2.1. The question is saying that one of the commonly used electrode is Calomel electrode. Under which of the following categories Calomel electrode comes? Okay, so you have to tell that under which of the following categories the Calomel electrode, it has a particular name, Calomel electrode, which category the Calomel electrode will cover from the given option. This question has been into the 2024 mains examination, and the options provided are gas ion electrodes, oxidation reduction electrodes, metal insoluble salt, anion electrodes, or metal ion metal electrode. Okay, so you got some time, try to solve it or try to remember that what is Calomel electrode, in which category it will come as per the given question. Okay, and then we will see what will be the answer. Okay, let's see. So for this given question, the correct answer is option C, that is metal insoluble salt anion electrode. So the Calomel electrode cover in the category of metal insoluble salt anion electrode. Now how? Let's see. So first of all, the Calomel electrodes comes in the category of this, right? Let me define that what is Calomel electrode. So in the Calomel electrode, the mercury is present and the mercury chloride, mercurous chloride, that is Hg2Cl2 is also present, which is actually Calomel as the name uh, is of this electrode. Okay, so Calomel electrode, Calomel is basically mercurous chloride, which is Hg2Cl2, and it is this electrode or is this cell is also having the solution of the KCl, potassium chloride. This is the overall, you can say, structure. You can say the structure of the electrode. As you also heard the standard hydrogen electrode, right? In the starting we have studied. So we are only studied that about the electrode. That means we are not talking about cathode, anode, or any cell. We are only talking about an electrode. Here, similarly, the Calomel electrode comes, where we talk about the Calomel electrode, and this structure is having a mug type of structure where the K cell solution is filled, and we have a rod here in the glass vessel, and the paste of the mercury and the mercurous chloride is present in that glass thing, and that hole is considered as calomel electrode, right? So it has a metal, that is mercury, so metal, insoluble salt, which is Hg2Cl2, and anion electrode. Okay, it has an ion, that is, it has KCl solution which has an ion Cl negative. So it is kind of calomel electrode which is coming under this category of metal insoluble salt anion electrode. Okay, so that's why this is the category from the given options under which the calomel electrode comes, and hence our correct option is the option C. Okay, okay, let's move on to our next question. So this question is again a JEE PYQ, and this is covering the NCRT section 2.4 in the NCRT textbook in our electrochemistry chapter. So the question is saying that identify the factor from the following that does not affect electrolytic conductance of a solution. So we have to tell the factor from the given options that does not affect the electrolytic conductance of any solution. That means which factor will not affect in any way the electrolytic conductance of the electrolytic solution. This question has been in the 2024 mains examination. The options provided are nature of the electrode used, concentration of the electrolyte, the nature of electrolyte which is added, or the nature of the solvent used. So you got some time, try to solve it and try to go at the concept of electrolytic conductance for a solution. Okay, and after this we will see the correct answer. Okay. So for this given question, the correct answer is option A, that is the nature of electrode which are we using. So among the given options, only the nature of electrode does not affect the electrolytic conductance of a solution. Okay. Other than that, whatever we have the options that will going to affect the electrolytic conductance, only what is the nature of the electrode which we are using in our electrolytic solution for the electrolytic conductance will not affect the electrolytic conductance of that particular solution. Okay, so that is why we have this option as our correct answer, that is option A as our correct answer. Okay, moving on to our next question. Again, this is a JPYQ and it is covering the NCRT section 2.5 from the chapter Electrochemistry. The question says that which one of the following statements is the correct one for the electrolysis of brine solution. So we are asking about the statement which is correct and which are given in the option. So the correct statement for the electrolysis process of the brine solution. Okay. So this question has been in 2023 mains examination. The options provided for this question are chlorine is formed at cathode, OH negative is formed at cathode, oxygen is formed at cathode, or hydrogen is formed at cathode. You got some time, try to solve it and try to go at the electrolysis concept which we have covered for the solution, electrolytic solutions, and then we will see that what will be the correct option. Okay, let's see. So for the given question, the correct answer is option B, that is hydroxyl ion, that is OH negative, is formed at the cathode electrode. So reaction which are involved in the electrolysis of brine solution. So as I said, you have to go at the electrolysis concept where we see that what is the reactions going on at the particular electrode, whether cathode or anode, right? So we have to go at the reaction which are involving in the electrolysis process of the brine solution. So NaCl is converting to Na positive and Cl negative. Okay. So first of all, the brine solution, if you know, it is a sodium chloride solution. Okay. So sodium chloride will dissociate into the sodium positive and the chlorine negative ions. Now at the anode, the two chloride ions are giving Cl2, that is the chlorine gas, and two electrons. It is also producing two electrons, right? So the two chloride ions are giving chlorine gas and also producing two number of electrons. H2O at the anode, similarly, the H2O molecule is dissociating into the oxygen gas and also producing 4 hydrogen ions and 4 electrons. At the cathode, so after the oxidation process happening at the anode, by the release of the electron, so chloride ions is releasing 2 number of electrons, H2 molecule is releasing 4 number of electrons. These are the reactions happening at the anode. Now at the cathode, the water molecule is gaining those 2 electrons released by the chloride ions and giving the hydrogen gas, which got which get to out. This arrow in the upward direction is representing a gas is liberating. Okay, so hydrogen gas liberates from, at the cathode, and 2 hydroxyl ions we will get at cathode, and also the 2 sodium positive ions are reacting with 2 hydroxyl ions and forming a sodium hydroxide, which is a base molecule. Thus, the OH negative is forming at the cathode. The question was that which statement is the correct statement regarding the electrolysis process of the brine solution. And as per the given options, the statement which is the right statement is that OH negative is formed at the cathode. Okay, thus OH negative is formed at cathode, as you can see also in our reactions given, that at anode we are getting chlorine gas and oxygen gas plus 4 protons and 6 number of electrons at anode by these two reactions, and at the cathode we are getting hydrogen gas and the sodium hydroxide molecule and 2 hydroxyl ions at the cathode, right, by these two reactions. So OH negative is formed at cathode. This is the correct statement given in our option. Hence the correct answer is option B. Okay. Okay, let's move on to the next one. Now again, this is a JEE PYQ and this is covering the NCERT section 2.4.1, actually subsection 2.4.1 under the section 2.4. The question is saying that molar conductivity of a conductivity cell which is filled with 10 moles of 20 milliliter sodium chloride solution is lambda M1, and that of 20 moles another identical cell having 80 milliliter sodium chloride solution is lambda M2. Okay, so what we are saying that the molar conductivity of a conductivity cell, we are talking about a conductivity cell. Remember, we have studied about the conductivity cell previously, right? Which we use to measure the conductance of a cell, Daniel cell or something, these type of cells, right? So conductivity cell is a specially designed cell. So the molar conductivity of a conductivity cell, which is filled with 10 moles of 20 ml, this much volume of sodium chloride solution. This solution has the molar conductivity of lambda M1, and if the conductivity cell is filled with 20 moles of another identical cell having 80 milliliter of NaCl, whose molar conductivity is lambda M2. So we have two molar conductivities, lambda M1 and lambda M2. The conductivities exhibited by these two cells are same. Okay, so the two cells which we are talking about, in which their solutions have different molar conductivities, but the conductivity which are exhibited by these two cells are same, then you have to tell the relationship between the lambda M2 and lambda M1. Conductivities, that means kappa. Kappa exhibited by these two cells are same, and you have to tell the relationship between the molar conductivities of the solutions present in both of the cell. This question has been in the 2022 mains examination, and the options are lambda M2 equals to twice of lambda M1, lambda M2 equals to lambda M1 by 2, lambda M2 equals to lambda M1, or lambda M2 equals to 4 times of lambda M1. So we have these four options, four choices. You have to select the correct relation between the lambda M2 and lambda M1 as per the given information in our question. So you got some time, try to solve it and come at the conclusion, and then we will see that what is the correct answer. Okay, so let's see. For this question, the correct answer is option A. That is the lambda M2, that is the molar conductivity of our second cell is equals to the twice of the molar conductivity of our first cell. So if you talk about the molar conductivity, it is given by kappa upon C, that is conductivity upon the concentration. Okay, this is the NCERT equation marked as 2.21 present in our NCERT textbook in the chapter Electrochemistry. So if you simplify it, or if you rearrange it, the conductivity, that is kappa, is given by molar conductivity multiplied by the concentration. Molar conductivity multiplied by the concentration. Okay, so from the question we know that the conductivities of the two cells are equal, right? The conductivity is exhibited by these two cells are same. That means the kappa 1 equals to the kappa 2 for the two cells, right? That means we can also relate these, right? So lambda m1 multiplied by the concentration of first cell equals to lambda m2 multiplied by the concentration of the second cell, right? Lambda m1 is representing the molar conductivity of first cell and lambda m2 representing the molar conductivity of second cell. Now, if you want to identify the concentration, it will be the concentration is basically the number of moles divided by its volume in the liters. Okay, so lambda m1 is the molar conductivity of first cell multiplied by molar conductivity of first cell multiplied by the concentration of the first cell, which is given by the number of moles divided by the volume in the liters. The number of mole is provided as 10 moles of NaCl solution. So we get it 10 divided by the volume. Volume is 20 but in milliliters. So we write 20, but for the conversion of milliliter to the liters, we have to divide the 20 by 1000. So when you divide the 20 by 1000, this 10 to the power 3 will go in the numerator, and that's why we are writing the term it as like that. 10 multiplied by 10 to the power 3 divided by 20. This 10 to the power 3 has been came by the unit conversion of milliliter to the liters of 20 of volume. Okay. Similarly, at the right hand side, so this quantity is equals to the lambda m2, the molar conductivity of our second cell, multiplied by the concentration of the second cell, which is the number of moles divided by the volume in the liters. Number of moles is given as 20 moles, so 20 divided by the volume, which is 80 milliliter, so 80. But for the unit conversion of milliliter to the liter, we are dividing the 80 by 1000, and this 10 to the power 3 will go in the numerator, and that's why we are writing this term. Okay, so we are relating these two terms. You know that only lambda m1 and lambda m2 are the variables. Other than that, we can solve everything, right? After solving, you can find a relation between the lambda m1 and lambda m2, which is coming out as twice of lambda m1 equals to lambda m2. When you solve this, this will be the equation finally, which you will get. Okay, so this is the relationship between the molar conductivities of two cell, and this is the correct way for solving this question. Okay, so the correct answer is option A, this relation, which is lambda m2 equals to twice of lambda m1. Okay. Okay then. Thank you so much for joining the session.